Hello! In this video, we're going to be talking about thermal energy transfer, the way that energy gets transferred between objects because of temperature. We are going to look at three main mechanisms: convection, conduction, and radiation. These are the three ways that heat can be transferred throughout the universe. This is topic 8. We're looking at 8.2, the second half of energy production. This is going to rely a lot as well on topic 3, since we're talking about heat and temperature and things like that. Thermal physics was where we talked about those ideas of heat and temperature and MC delta T, all those kind of things. So first, I have a quick review of some of those important concepts from topic 3 before we jump into looking at convection, conduction, and radiation. So as a reminder, this is, again, topic 3 material. Thermal energy is what we are talking a lot about still in this unit, because we're talking about heat. And heat means thermal energy. The most important thing for this to remember is that heat is measured in joules. Heat is an amount of energy that flows from place to place. You might recall heat flows from warm to cool. You put an ice cube in your hand. There are different temperatures. Heat will flow from the palm of your hand to the ice cube. There's no such thing as cold flowing. The cube doesn't make your hand cold. Your hand donates some of its heat to the ice and causes it to melt. So that's heat. We're going to be talking a lot about that heat transfer. But what we're going to look at is how exactly does that happen? What's going on to make the heat from the energy in your hand transfer to the ice cube? How does that heat actually flow? One other thing to please keep in mind, again, from topic 3, is when we first talked about this, temperature is its own thing. Temperature and heat are not the same. That's a very common mistake that's easy to make because we kind of use them interchangeably in our everyday life. But temperature is very specific. It's a measure of the average kinetic energy of the molecules of a substance. So temperature is certainly related to heat, but temperature is a way to measure on average how quickly the molecules of a substance are vibrating. So you want to remember that when you have like a glass of water, as if you leave it out and it starts to get warmer, what's happening is all of the little H2O molecules are constantly vibrating and kind of swirling around each other. And as it warms up, they're doing that quicker and quicker. They vibrate more and more frequently. There's more jiggling. So the vibration corresponds to temperature. And a glass of water that feels hot compared to a glass of water that feels cold, the only difference is the H2Os on average in the hot water are doing a whole lot of jiggling, and the H2Os in the cold water are not jiggling quite so extremely. All right, here's another picture. So again, this is how you want to think of temperature. Temperature is based on energy, but it isn't energy. Temperature we measure in like Kelvin or degrees Celsius. All right, so make sure you have a clear idea in your head of heat and temperature. Again, check out topic 3 for some more in-depth review of that stuff. And don't forget as well that whenever you're doing math with temperature, which we will, we're going to use Kelvin. And there's a conversion conveniently in your data booklet to remember this magic 273 number. It's a very weird conversion because it's not a multiply thing, it's an add thing. So it's really just a shift of the Celsius scale. Okay, but let's get into the new ideas of conduction, convection, and radiation. So these are the three ways that energy gets transferred, and conduction is the first, and it's maybe the simplest. It's honestly the one that we mostly talk about in topic 3. This is transfer of energy by contact. So this is when two things are touching, so the collisions between the molecules and the electrons directly bumping into each other causes heat to transfer. When you're holding the ice cube in your hand, the molecules on the surface of your hand are jiggling back and forth real quick, and the molecules on the surface of the ice cube are not jiggling very fast at all, and your hand atoms are just pummeling the ice cube and making all of the little H2Os that are frozen in place jiggle until they kind of break apart and start to flow past each other and become water. It's just transfer by contact. Here's another animation that shows that idea with a flame, and this is meant to be the air. These are molecules of the air, which of course are invisible, but they're there. And this is the idea, right? There are air molecules right next to the flame, which are maybe nice and cool, but as the flame is lit and starts to warm up and transfer heat to the air, the way that happens is the molecules of the flame, the plasma that makes it up, are vibrating back and forth very quickly, and they collide into the air molecules. They are smashing against them, causing them to bump into the next one and bump into the next one. There's this chain reaction of vibrations that goes and spreads throughout the air as the air molecules start bumping into each other faster and faster from the collision of the flame. And so it spreads out that way. So this is simply the spreading of heat by contact. It is just this idea that we've talked about before of jiggling atoms causing the others to jiggle through bumping. There's another type of thermal energy transfer which is called convection, and this happens when you have a fluid. The classic example is you're going to go make some pasta. You're going to make yourself some mac and cheese. So you get a pot full of water, you stick it on the stove, you turn on the burner, you wait for it to boil. Convection is what allows that to happen in such a nice uniform way. This is transfer of heat through a fluid, and density comes into play. Here's the idea. Here you go. You got your pot of water on the stove. You're getting ready to cook yourself some linguine or something. There's a flame or perhaps an electric burner down here that heats the bottom of the pot. That's conduction. That's direct contact. And the water at the bottom of the pot is also heated by conduction. It's touching the bottom of the pot here. But what happens is that water gets warm, but because it's water, it's a liquid, it's a fluid, it's going to get less dense and rise. It's the same idea that hot air rises. The molecules spread out a little bit as it heats up. And so as it gets a little bit less dense, it's going to rise up to the top of the pot. But now it's further away from the flame, so it's going to start to cool down as it gets up there. And now that it cools down, it gets more dense and it starts to fall. And you get this cycle. So it gets the heat gets transferred by conduction at the bottom, causing it to rise and cool and fall, and heat and rise and cool and fall, and so on and so on. You get this really convenient effect that mixes all of the water or the air in, say, a convection oven, same exact idea. Mixes it all very nicely. You have a really uniform temperature throughout your fluid because of this kind of natural stirring that happens. It's not like when you put on a pot of water that the water at the bottom boils first because it's close to the flame. This is the reason it's called convection. There's one more way that energy can get transferred. Both of these, conduction and convection, require some kind of contact. However, you might remember from the beginning of topic 8 that the vast majority of all of the energy that we have or use on Earth comes from the sun, one form or another. Not just talking solar, we're talking, oil comes from dinosaurs that have been smashed under the rocks for millions of years, who ate other dinosaurs who ate plants, and the plants got their energy from the sun. The sun has given us all of the energy that we use that's not like nuclear energy or geothermal, or a couple very specific things. But the thing is, the sun is way far away from us in the middle of empty space. And there's a whole bunch of space in between us and the sun, which is nothing. It's empty. It's a vacuum. It's not air. There's nothing there. There's nothing to transfer that vibration physically through. So somehow energy gets transferred through that medium. We know of one thing that transfers energy through the vacuum of space, and that is light. And so that's the last way that energy can get transferred, is by thermal radiation, aka light. You might recall I would be impressed if you did, but you might recall that the way that light, an EM wave, gets created is by the acceleration of a charged particle. If you have an electron accelerating, it's creating light. It's creating an EM wave. So even if you're talking about a little H2O, guess what? There's electrons zipping around your H2O. There's protons in that H2O. And if the H2O is vibrating back and forth, so are the electrons. They're moving left and right, then up and down. They're constantly changing direction, which means they're accelerating. And if these charges are accelerating, that means they're going to create EM radiation. They're going to create some form of light. Maybe that vibration is so violent that you actually see visible light and it like glows red hot. Maybe it just gives off infrared and you give off heat and you could see it with night vision goggles. But either way, this is what we call thermal radiation. Anything vibrating, which is everything, anything vibrating will create waves, light, electromagnetic radiation. That light carries energy away. So the sun is a roiling ball of violently vibrating plasma. You have electrons just sloshing back and forth all over the impossible to imagine gigantic sun. And as they do, they create light waves. Those light waves travel through empty space, and a tiny fraction of that energy makes it to our planet and powers everything that we do. So thermal radiation is that last way. The generation of light by vibrating particles. That's the one that we're really going to look into the details of as we continue this topic. But here's the summary. These are the three main methods that are used to transfer energy from one object to another. Conduction is by contact. Convection is fluid moving around and changing its density. And thermal radiation is transfer through light. All right, so that's your intro to these three different ways. Like I said, we're going to be getting into thermal radiation in a big way. So look forward to that. Have fun.